Alright, this is 5.6, finding rational zeros. So let's say we had this polynomial here. Let me just explain it really quick. We start at at a coefficient, which is really just a constant term, and then we would move up to the x term and the x squared, x to the third, x to the fourth, and we just keep moving up until we're to the highest power. Okay, so this highest power might be just 2, or it might be 3, or something like that, but that just represents the nth or the highest power that you see in this polynomial, the one that gives its degree. And this is just the nth coefficient, okay? And this is the coefficient before that, and the x with the power before this one, and all the way down to the constant term, the zeroth coefficient within technically an x to the 0, which is just anything to the 0 is 1. So anyway, so we have this polynomial, and let's say we're given some 0, right? Something that you put into the function and get a 0. So say that is k, right? Then we would set up this, to find the rest of the zeros, we'd set up this synthetic division a la 5.5, and we'd put a sub n minus 1, all the way down to a sub 0. All those coefficients, we put k out here, and then we'd find all of, we would find a b sub n. Well, it'd be really like b sub n minus 1, kind of like the same power here. And b sub n minus 2, and all the way down here to b sub 0. Right? Which would be, actually this would be 0, because this is a 0, and that would come out to be 0. And then we'd have this new polynomial, and we would factor it, and so on. That's great if we're given this 0 here. If we're not, though, there's something called the rational zero theorem that helps us to find possible zeros. Right? If we didn't have a 0 here, and we wanted to find all the zeros, we would pretty much be left to guessing and checking, unless this is a really easy factorable polynomial. So we'd just be guessing and guessing and guessing and guessing, and what the rational zero theorem does is it narrows our search of guesses to ones that are the only kind that could possibly show up. Okay, so what I mean by that is there are only going to be certain kinds of, or certain types of numbers, or numbers with certain qualities that are going to work to be put into this polynomial and get a 0. And we'll just call it the rational zero theorem. And the rational zeros are going to be p over q. Okay, certain kind of number p, a certain kind of number q. P is a factor of the constant, and q is a factor of the leading coefficient, right? Or in this case, since we have this all written out, we'll refer to this guy here specifically. Factors of the constant is that a sub 0 term. Factors of the leading coefficient is a sub n, right? The constant is this one that doesn't have an x. And remember, this I've written an x here, but it's to the 0, and anything to the 0 is 1. So really all that is here is a sub 0, that's the constant term. That's the one that's no x by it. And up here, the one that is next to the x of the highest power is the leading coefficient. So you take factors of this guy here, divide them by factors of this guy here, every possible matching of a factor of this number with a factor of this number, and that is the only kind of number, the only type of number that could possibly be a 0. It's not guaranteed that it will be a 0, but it's a better chance than just randomly picking numbers for what could be a 0. Going this route, we may have chosen 3 for this to possibly be a 0, just as a guess. But as we do this, we wouldn't find 3, just for instance. Okay, we may guess 3 here, but we'll find out doing the rational zero theorem that, oh, for this problem 3 is not going to work. Okay, so the thing to take away from this is that we're going to take polynomials. We're going to make a list of guesses. That's all we're doing, really. But it's a smaller list of guesses than all of the numbers ever. We're going to make that list of guesses with this, the rational zero theorem. Okay, and we're going to take factors of the constant over factors of the leading coefficient and make our list of guesses. Okay, and we will do those specific things in the sample problems video. Thanks for watching.